So we are going to find economic order quantity or EOQ using some math. Okay, so what is EOQ? So economic order quantity is where our ordering cost and carrying cost is minimum. Okay, so it's minimum point. Now, where this is coming from? So like we are thinking from the angle of purchase department. Okay, so like for purchasing product we need purchase cost, obviously cost of the product. Also for each order we incur some cost associated with the order, like invoicing, many more, etc. So that's ordering cost, which depends or which is a function of the number of orders. Okay, and carrying cost is cost of maintaining the inventory. So like after purchase, so that's our cost of maintaining that product. Okay, so our goal is to find quantity, which is also known as EOQ, where both the costs will be minimized. Now how can we go about that? So so first of all, ordering cost and carrying cost. Okay, now so order depends upon how much the material we want. So in a year, okay, what is our annual requirement of the material? Okay, so if we need in total 10,000 okay material, then we will find how much we should order at a time. Okay, like once at a time. So we will get also the number of times we have to order. So that's like our EOQ. So I will say annual requirement equals to A. Okay, so let our annual requirement be A, and economic order quantity be R. So our frequency of order, so number of times we will order, is what will be it? Frequency of order. It's just our total requirement A, and how many times or how much quantity we will order each time. So like R. That's EOQ. Yeah. That is our goal is to minimize. Sorry, our goal is to find the R where OC, that is ordering cost and carrying cost, will be minimized. Okay, now ordering cost. Let's think about ordering cost. So as I tell, ordering cost is a function of how many orders I am placing. Okay, or A by R. So now since ordering cost is just a linear function, like it will increase linearly for each order, we will take a constant step each time. So for each and every order, we will take a constant step in the cost. So it's just a linear function. How can we write ordering cost? So ordering cost is just some constant K. It's the factor by which we will increase into A by R, into number of orders. Correct? K into A by R. So K can be 50, 100. So it is like what is the cost of one order, suppose. Okay, so for each time, suppose we need 100, so it's 100 into A by R. Now carrying cost. Now carrying cost we take, it's like cost of maintaining the product, okay, or inventory. So we generally take carrying cost as the cost we need per annum on a unit. Okay, so we take it as per annum per unit. So like 10 rupees per annum it cost, okay, for each and every unit. Now for the total inventory, it's just going to be that the total inventory into cost per unit. But since carrying cost is not the constant always, it depends upon the inventory level. So for simplification, we will take on average inventory. Okay, so it's like simplifying. Okay, so so that statement we can write as some constant Q times R by 2. So it's just saying that carrying cost is some constant Q, which is its cost we will need per unit, into R by 2. So R by 2 is on average inventory. So carrying cost is Q into R by 2. Simple, okay? So suppose our R is A. That means if our total economic order quantity is same as annual requirements, that means we are purchasing all 10,000 at the same time. That will imply we are taking on 5,000 units carrying cost. So on average inventory. Okay, so it's just a simplification. Okay, now we are ready, but just for simplification I am assuming A. Okay, now this is simplification. So A, suppose it's 10,000. A is 10,000. So we can write ordering cost as K times 10,000 divided by R. Carrying cost is Q times R by 2. Now since K and Q are constants, and let our variable is R, so like we will allow R to change. That means this is a function of R. So like f of R is equal to 10,000 times K upon R. Okay, so our ordering cost suppose is a function of R, and we will allow, basically A is constant and allow R to change. Also here we are like G of R also same, Q times R by 2. Okay, now we have to minimize the total cost. That means ordering cost plus carrying cost. 10,000 K upon R plus QR upon 2. Okay, so suppose this is Z of R. Now we have to minimize this. Okay, so our goal is to minimize this, and then we will get R, or our economic order quantity at the quantity at which we should place the order, so as to minimize this. So again we are going to minimize this in the next part.